Hi and welcome to my channel. Let's firstly talk about virtual MACs in ClusterXL. So by default, when you configure a checkpoint cluster, VMAC is not enabled. That means each cluster member responds to ARP requests using its own physical MAC address, even though they both share the same virtual IP address. So any other network device will have the active cluster member MAC address as the MAC address of the virtual IP address. So here we can see that we have this virtual IP, and if this is the active gateway, so this IP will use the MAC address of this interface here. And at the same time, if this is the active, it will use the MAC address of this device. But if we activate virtual MAC, this IP or the virtual IP will have its own MAC address. So let's take a look at our topology here. So let's run our router or open it. So we can use the command show ARP here. And here we can see that this is the virtual IP. It uses this MAC address. And we can see that this MAC address is the same as this MAC address, or the same as 3. So this one, this is the active. This tells us that this is the active node or the active gateway. So this causes a problem. After a failover, the MAC address associated with the virtual IP changes. This leads to MAC address flapping, and some switches or routers may take time to update their ARP cache, delaying packet forwarding. And to solve this, Check Point introduced the VMAC or the virtual MAC. With virtual MAC enabled, both members respond with the same virtual MAC for the virtual IP address, regardless of who is active. This eliminates ARP learning delays and ensures faster failover. So let's grab our smart console here to show how to activate this MAC address. So we double click on our cluster and ClusterXL and VRRP here, and here we can see use virtual MAC. So check this, click OK, and we need to publish and install. Just wait a sec. So, install policy, publish, and install. Let's open this. So with virtual MAC, MAC remains the same. The MAC address remains the same. No ARP update, smooth traffic flow. So enabling VMAC in ClusterXL ensures a more stable and seamless failover experience, especially in environments where traffic sensitivity and high availability are critical. So let's wait until this is done, so then we can show the difference on the router. So now our policy installation is done here. So let's go back to our router here and run the same command again. So show ARP and show ARP. Now we can see that the virtual IP here has got a new MAC address, its own MAC address. So now state synchronization is critical in a cluster, especially for session handling. But imagine syncing thousands of connections every second. That's where Delta Sync helps. So Delta Sync means rather than copying entire tables, it only syncs the differences between them. So from CLI, we can use the command cphaprob syncstat. So let's open our gateway here and see and use that command in action. So cphaprob syncstat. sync. Okay, we need expert mode done. So cphaprob sync stat, something like this. So it is important here, what is important here, that we can see what interface is used as the sync interface, link speed, how much data are we changing between this one and this one. Okay, this is a lab, it is maybe 1 hour up, so it's not so much in size. And here we can see the delta sync interval 100 milliseconds. So it is syncing 10 times in 1 second. So it is very important. And in our lab, we can use Wireshark to see what kind of messages are being sent between cluster members or sync interfaces. So if we look here, so let's right click here and capture this interface, the ETH one. So let's open that. Now, so here we can see it's new sync packet, as you can see here. So the traffic, you can encrypt the traffic between these two or not encrypt it. It's up to you. Cluster Control Protocol, or CCP, by default is using UDP port 8116. Cluster Control Protocol encryption in Check Point clusters is designed to secure the communication between cluster members. So the purpose of the encryption is security. So CCP encryption ensures that the communication between cluster members is secure, preventing unauthorized access or tampering with the data exchange. And integrity. It maintains the integrity of the data being synchronized between cluster members, such as state synchronization and health checks. So how CCP encryption is implemented? By default, CCP encryption is enabled in Check Point clusters. We can use the command show cluster members CCP inc. So let's run that command here. So exit. So show cluster member CCP inc. And we can see it is off on the other. So let's check on this side, and that is not okay. When we activate it, we need to activate on both sides. So show cluster member CCP off. So it is off on both sides. But this means that all communication between cluster member is encrypted unless manually disabled by an administrator. So we can disable that, or you can disable it using the command so set cluster member CCP inc. And here we have the on or off. So let's take it on both. And this is 1, this is 2, set cluster. And now we can see, now when it is encrypted, we can see the port. Set cluster member CCC on. And now we can see the port. So it is using this port 8116 when the encryption is on. So if CCP encryption is disabled due to errors or issues, it is automatically re-enabled during the next policy installation, a boot or restart of Check Point services, unless it was manually disabled. So synchronization across members, it is crucial to run these commands simultaneously, as we have seen. So both should have the same command, on or off. So simultaneously on all cluster members to prevent any communication issues such as a split brain condition, where one member has encryption enabled while others do not. You can show the CCP encryption key by using this command. So we have a key. So let's shut down this here. So we can go to expert mode. And we have a command that shows us the key. So the command is cphaprob CCP encrypt key. So cphaprob CCP encrypt key, and here you can see that this is our key. That key can be configured manually if needed by using the command cphaconf. So if you need to change that key for any reason, so you can use the cphaconf. Let's try CCP encrypt key, and then you need to type the key that you need. So let's try anything here, something like that. Okay, we have missed here. So this command can be used to change that. So CCP encryption key must be either 16 or 32 bytes. So lastly, a very important command is the cpstat -f all. So let's type that cpstat all, this command. So let's have a bigger screen here, something like this, and you can see here much information. So this command is used to display detailed high availability status and statistics for a checkpoint cluster. The cpstat HA is used to query the high availability status of the cluster. It provides information about the state of each cluster member, their roles, active or standby, and other HA related metrics. The F flag specifies the flavor or type of information to collect. Using all as the flavor means that the command will return comprehensive information about HA status, including all available statistics and details. So we can see here high availability, version 6, status short is okay, high availability active up. You can see here interfaces. We can see here if any problem, so status is okay. You can see status of all of everything here. You can see cluster IPs, these are IPs. And here we can see the sync table. So we have another command, so cphaprob, I think it is -AF, something like that. So this shows us the MAC address, the virtual MAC address. So as you can see, this is also an important command. So this command, the cphaprob -AF, shows us the virtual IP that we are using. So as you can see here, both interfaces are using the same virtual command, virtual MAC address. So the output of that command let's go back to this one. The output of this command will include various metrics such as the status of each cluster member, synchronization status, and any issues detected within the cluster. This is particularly useful for administrators to monitor and troubleshoot HA configurations. So this video is done here. So thank you for watching and see you in the next video.